Today we will discuss deserts and the work of wind in shaping landforms common in many of the world's deserts. First, there is something of a misunderstanding about what a desert is. People generally think of them as being hot places. However, many deserts are cold, such as the polar and Antarctic areas. I understand that certain of the people who inhabit the Sahara Desert say that Sahara is a cold place where the sun shines very hot. I myself have lived and worked in the Chihuahuan Desert. In fact, the coldest I have ever been in my life was in July in the Chihuahuan. It is not uncommon for people to find themselves stuck out in the desert to become quite cold after the sun goes down. The low humidity allows temperatures to vary as much as 30 to 40 degrees between day and night. So what is a desert? Our textbook defines a desert as places that receive less than 25 centimeters of rainfall per year on average. That's about 9.8 inches for the rest of us. Other authors have used other numbers down as low as 6 inches per year. Now, the first term we need to understand is desertification. It refers to land which has been productive becoming deserts. This is a problem affecting hundreds of thousands of people who become refugees. Sand-sized particles bounce along the surface driven by winds in a manner we call saltation. This is the bed load. Fine particles can be picked up and transported by strong wind as a suspended load. Wind erosion by abrasion and deflation. Deflation is when fine-grained particles are picked up and become part of the suspended load. The ground level actually drops until the larger particles fit together in such a way that silt can no longer be picked up by the wind. We call the remaining protective surface desert pavement. Abrasion is like sandblasting exposed rock. This can cause a type of landform diagnostic for wind erosion. In places where there is relatively harder rock sitting on a softer layer, it will become worn out in such a way that we find a large rock sitting on a tiny pedestal. There are other features such as yardangs, which resemble boats, hulls turned upside down, and can be quite large and often found in clusters. Wind can also deposit sand as dunes and dust as loess. We are all familiar with sand dunes. North Africa is a huge area of dunes, as is Saudi Arabia. There are many other areas of dune fields, both large and small, throughout the world. If you get a chance to visit White Sands, New Mexico, you will find the sand is not quartz like we usually think, but gypsum instead. Now, dunes can migrate, covering entire villages unless they move one house at a time before the advancing dune. Sand-sized particles will bounce up the windward side of the dune by saltation and drop down the slip face. We normally recognize 4 types of dunes. These are bark-end dunes, which are crescent-shaped with the horns pointing downwind. These often occur in areas where there's constant wind direction and limited sand supply. They can grow to 30 meters high and can move up to 10 meters per year. Parabolic dunes have the horns pointing into the wind, often anchored by vegetation. These are quite common along the coast where there's abundant sand and strong offshore wind, and are often referred to as beach dunes. Transverse dunes are asymmetrical ridges roughly transverse, or about 90 degrees, to the wind direction. These occur in areas where there's an abundant supply of sand. 2 bark-end dunes can grow together to form a transverse dune. In this illustration, imagine the dune coming out of the page toward you. Longitudinal dunes, also called linear, are long and fairly straight dunes that form with the general direction of the winds. These form in areas of limited sand supply and variable winds. They can grow to cover over 100 meters high and extend over 100 kilometers. And lastly, a star-shaped dune is an isolated hill of sand, roughly resembling a star in shape. They tend to remain in one place in areas where the wind blows from all directions. They can grow as high as 100 meters. Loess deposits of silt and clay. Often this fine material is glacial, floodplain, or desert in origin. In China, people have dug homes back into these, which are probably cool in summer and warm in winter. The Coriolis effect, caused by the Earth's rotation, breaks the atmosphere pattern into 3 cells in the northern hemisphere and 3 cells in the southern hemisphere. Where these rise and fall often contributes to where deserts form. See your textbook for a diagram illustrating this, or look up Hadley cells online. Where there's moist air blowing in from offshore and rising as it meets a mountain range, we will get rain shadow deserts. The air must rise in order to get over the mountains, and as it does, it will cool and often fall back as rain or snow. On the leeward side, the downwind side of the mountains, the now dry air will descend and warm up. This will conclude our discussion of deserts. Be advised that this is only a very basic introduction. If you're in someone else's class, make sure that you cover any other information on which you will be tested. See you in the next video.